Hello, Chemistry 20. Welcome to the third podcast of week 3. And we're moving into our third concept, which is molar concentration. This is one of the absolute most important integral concepts for you to get out of Chemistry 20. It's a big one, it's important, and it introduces a new formula to you that you will continue to use for the rest of your chemistry career. Now, ultimately, concentration can be measured in many different ways. Concentration, by definition, is just how much of a solute is dissolved in a given amount of solvent. So you can see how this works into solutions beautifully. That's what a solution is, a given solvent dissolved in a greater amount of something, which is a given amount of solute, which is dissolved in a greater amount of something, the solvent. Anyway, molar concentration is the one we're going to focus on. Honestly, if we were in class right now, we would have done a whole bunch of other types of concentrations first. But given our scenario where you at home learning less content than you would in class, this is going to be our fixation instead. Now, to do this, we compare the amount of solute, like I said, dissolved, and this is supposed to say volume, not volume, anyway, dissolved in the total volume of the solution. Key thing, here are your units for this. It is measured in moles should be familiar to you, per liter. Notice that it's in liters, not milliliters, not kiloliters, etc. That's important. All right, check out a formula. Dun, da, da, da. This formula is on your formula sheet, which is great. And ultimately, what it stands for here is that C is representative of what we call molar concentration. Why? Because it's in moles. Now, the units are really, really important here. No exception, moles per liter. So whenever you see a number with the units, moles per liter in a question, you know that you've just been given a concentration. Now think about those units and then think about how logical this formula is. Moles over liters. Well, that's what N is. N is the amount of solute, in, of course, mole. There's your units. And V, of course, is your volume of the solution that you have, which is going to be in liters. Always see the units, moles per liter, and indeed we have moles over volume. Just to give a little side note, because we're dealing with a molar amount, this formula, N equals mass times molar mass, is going to be super useful, right? Because you can see that we've got N number of moles in both of them. So please keep that in mind, that you're going to be using both of those formulas an awful lot for these next few questions. We're back to the calculations. Let's check out one. First, just a little side note here. Shorthand notation, guys. This is going to come up again and again in chemistry. See, please, the square brackets here. So these square brackets are used to represent specifically molar concentration, okay? So if you see square brackets from here on in, that's what that's trying to, in a shorthand way, communicate to you. All right, here we go. First question. This, of course, is the example that's on your sheets. Calculate the concentration. So consider our purpose here. We're looking for C, and it tells you what units, moles per liter. And then you're told that this particular solution has 1.3 moles. You just got given your N value. Take note of ammonia. This eventually starts to come in handy in other questions. And last but certainly not least is this. It doesn't tell you this is a volume, but guys, take note. When you see milliliters, well, yeah, this is a volume value. This was your number of moles value, and we're looking for the concentration. Similar to the past, write down what you know. So we know that N is equal to 1.3 moles. We know that the volume is equal to 1,375 mils. Mils is not good enough. We're going to have to take this and convert it to liters because concentration is always moles per liter. How do we do that? Well, you divide by 1,000, or vice versa, you could times by 10 to the negative 3. Either way, we have 1.375 liters. Okay. Now, our goal of this question is to find C. Our newly introduced formula is C equals N over V. I don't have to rearrange this at all. I'm looking for concentration. I simply need to plug in what I know with, of course, my units. 1.3 moles divided by 1.375 liters. We're going to end up with a grand total of 0.9454. It keeps on going, of course. And look at the units. The moles is being divided by the liters. And there it is. We need 2 sig digs here as determined by the number of moles, 1.3 moles. So our correct answer when all that is done is for 2 sig digs, 0.95 moles per liter. And that, folks, is how we use a new formula, which really, this particular question is super doable. No big deal. What if we put a little bit of a spin into it? What if I don't give you the actual number of moles, but I give you a mass? All of a sudden, knowing the substance that we're working with is a big deal. Now, this is a solution, so we're still taking a solute and dissolving it into a solvent, in this case water. How much solvent are we using? We're using 3.75 grams. But take note, that is a mass, not a number of moles. And you're putting this into 350 mils of water. Well, milliliters, of course, is a volume. It's not the correct units yet, but we'll get there. The whole point of this question is to calculate the molar concentration. Molar. So we are looking for C. C equals question mark. V, let's go back to this because this is a given, 350 mils. Take that, either divide it by 1,000 or times it by 10 to the negative 3. Either way, we have 0.350 liters. Now, N, the number of moles, and we're going to have to play with this a bit. Start with the mass. Mass is 37.5 grams. But remember what I told you at the beginning is that we're going to be able to take this and know that N is equal to mass over molar mass. Oh, you know what I just realized? I had a wrong formula over here. Oh, wasn't that silly of me? Look at this thing going back. Sorry about that, guys. This should be N equals M over M, not like this. Hopefully you listened far enough to fix that thing. Okay. Anyway, going back here. N equals mass over molar mass. Okay. So if this is the case, and we've got mass over molar mass, well, we need to make sure that we actually have the molar mass of our magnesium bromide, which means correctly predicting the formula. Magnesium is a 2+ charge. Bromine is a Br negative charge, so we need 1 magnesium and 2 bromines. Our molar mass of that, if you do some number crunching, you will get 184.11 grams per a mole. All right, so far so good. Now go back to your formula and you can plug in what you know. Mass is 37.5 grams. Molar mass 184.11 grams per mole. We will cancel out our grams and we'll be left with moles, which is exactly what we want. Now be careful, do not round yet. You're going to have to use this number again. 0.20368. It keeps on going, of course, moles. We're close. Concentration, our new formula, C equals N over V. And fortunately, you just found out N, which can go in here. So N, which we just calculated, 0.2036. Remember, unrounded value because you're using it again. Volume in liters, 0.350 liters. Number crunch, we need 3 sig digs as dictated by the question. You will get a concentration of 0.582 moles over liters. And that is our end concentration. All right. Hopefully that's feeling okay. You're building on skills from last week with molar mass and adding it into a new formula. On to the last question. Check out this one. The whole goal of this question is to calculate the volume. So this time we don't know what V is. Now notice something. I don't tell you that this next value is concentration. However, you should be able to figure that out by seeing the moles per liter. As soon as you see that, you know you have concentration. Keep on going. A little bit of a twist here again. You're told the substance, calcium sulfate, which comes in handy, and then you're told a mass. But be careful with this. Yes, this is a mass. It's in milligrams, not in grams. And to figure out the volume, we're going to need the number of moles, N. Definitely a fair bit of work that's going to happen here. Go back to the beginning. Our whole goal is to find V. Our concentration is a given, 1.8 times 10 to the negative 2 mole per liter. Okay, keep going. The mass, you're going to have to do a conversion. The mass is equal to 350 milligrams. I can take that little m and replace it with what milli stands for on your data booklet. Milli stands for times 10 to the negative 3. So I can directly replace the m with this. Everything else stays as the same. So I'm going to have 350 times 10 to the negative 3, and now that's a gram. There's our mass. We need molar mass in order to convert this to number of moles. It's molar mass of calcium sulfide. Calcium, think back, is a Ca2 plus charge. Sulfur is an S2 negative charge. It's a 1-to-1 ratio. Hence, I only need 1 calcium and 1 sulfur in my formula. When you number crunch that from your periodic table, you will get an answer of 72.15 grams per mole. Okay, let's start to get from our mass and molar mass what N is going to be. All righty, here we go. N equals mass over molar mass, which is going to be equal to, remember how we converted this, 350 times 10 to the negative 3 grams, put it in brackets so the whole thing goes together, divided by the molar mass, 72.15 grams per mole. Those grams will cancel out, we'll be left with moles, and our number of moles is going to be equal to, don't round, 0.004851 ... moles. Take that now, and we're going to have to play around with our formula, right? Because if C is equal to N over V, our goal is to get V by itself. Okay, it's stuck on the bottom right now. That's no good, guys. So our first step here is actually to get it up to the top. So times by V on both sides. This way, at least, it's no longer in the denominator below. So that'll cancel out. It's still not done. I now have V times C equal to N. I need V by itself. This is our goal. We're closer because it's not stuck on the bottom anymore. But divide out by C on both sides, then the C will cancel out. We have a rearranged formula of, and I'm going to go all the way up to here, V is equal to N number of moles over C concentration. Okay, N was figured out before, 0.00485, it continues, mole, divided by the concentration given to you in the question. Be careful, make sure this is in brackets so that you account for your scientific notation. 1.8 times 10 to the negative 2 moles per liter. Good news is my moles are going to cancel out. And when you number crunch all of that, don't forget we're dictated by the 2 sig digs in the original concentration. The answer is 0.27 liters for volume. If you wanted to, you can convert this to milliliters. If you did that, you'd have to times by 1,000, so we'd get 2.7 times 10 to the positive 2 mils. Either answer is good. Okay, hope that feels okay, guys. Go back and listen again if you're feeling stuck at all at any point. There's quite a few opportunities for you to practice those questions in today's assignment, or this week's assignment, I should say. Speaking of which, you're now at the point where you need to do number 3, 4, 5, 6, 7, 8, and 9 to complete this assignment. Don't forget, this one is due on Friday of this week at midnight. So upping the due date a little bit because lucky you have a week off for Easter. All right, take care. Talk to you soon. Bye-bye.